On, Mr. Riley, Nathan Simpson here, and I'm here to present my Apollo 13 presentation that's for our Project 4. So here we go. This is Apollo 13 by Nathan Simpson. Let's get started off with the explosion. During the Apollo 13 mission, the spacecraft's heaters were disabled after an explosion. This caused the cabin's temperature to drop steadily. The climate temperature around the cabin was negative 60 degrees Celsius, but before the explosion, the cabin temperature was around 20 degrees Celsius. Find the amount of time that it took for the cabin to cool to 5 degrees Celsius with a cooling rate of negative 0.012. And this will be for our first problem. And then, after you've discovered the time, calculate the temperature after 40 minutes with no heater. Once this is done, compare the temperatures to discover which one is more dangerous to the human body. So that's our problem will be, our two problems that we'll be having. So the first one is to locate the time. So our starting temperature is 20 degrees Celsius and ending temperature 5 degrees Celsius. The climate temperature is negative 60 degrees Celsius and our cooling rate is negative 0.012 and we are missing our time. So using this cooling rate formula, we will use it to calculate the amount of time that it took for the cabin to reach 5 degrees Celsius. Moving on. So this is our work that we did for completing the problem. So, okay, to set it up, our ending temperature was 5, so that goes first. And then negative 60 for our climate temperature on the end of both problems, because that is our climate temperature. And then starting temperature would go right here. And then we fill it in for the K, which is the cooling rate, and it is negative 0.012. So then we just solve it, it goes down. And then that's pretty much all the math I used. And then it ended up being 17.3, which we just round to 17, so approximately 17. So the time. After the cooling rate formula after using the cooling rate formula, the Apollo 13 cabin would take roughly 17 minutes to cool from 20 degrees Celsius to 5 degrees Celsius. So that's the end of our first equation, or problem. And on to part 2. And we have to locate the temperature after 40 minutes. So the starting temperature would still be 20 degrees. And the ending temperature, so now we don't have the ending temperature because in the first problem we had 5 degrees Celsius. So now we're having to locate the ending temperature after 40 minutes. So then our climate temperature is still negative 60 degrees, cooling rate still remains as negative 0.012. And then, so using the same exact cooling rate formula, calculate the temperature of the cabin after 40 minutes. So here we go. So this is the math that we used. And so now we're missing our ending temperature. So we still use negative 60 because it's our climate temperature, and then our starting, which was 20. So now we have these two, or we have the, the time now, which we were missing in our first equation. So you just pretty much solve it down. That's what I did. And then I ended up getting negative 10.48 degrees Celsius, which I just roughly rounded to 10.5 degrees Celsius, or negative 10.5 degrees Celsius, after 40 minutes. So then at the end, this is our temperature comparison. And after approximately 17 minutes without a heater, the cabin reached a temperature of 5 degrees Celsius. And then for our second equation, after 40 minutes, the cabin reached a temperature of negative 10.5 degrees. So, this means that after 40 minutes, the cabin temperature was negative 15.5 degrees Celsius colder than 17 minutes, which made the cabin far more dangerous for the astronauts after 40 minutes. And this is my Project 4 presentation, so if you have any questions or anything, you just let me know. Thank you.